finish chapter or section 9.1 in the book today and hopefully get to 9.2. But we're going to spend our time the first half of class anyway talking about the types of errors that can happen when you perform a significance test. Remind me real quick what the conclusion is in a significance test. Remember, we talked about this before, 5 steps. And if you're not sure what those 5 steps are, I think your book talks about 4, think, plan, do, conclude, I think is what they call it. I like to break it down a little bit more than that. Remember what we said here? Let's review this real quick, especially for those people who are out. When you do a significance test, I tend to call them hypothesis tests, so forgive me if I say the wrong word or the other word. What's the first thing you're talking about? What do we do? Do you remember what we said? Huh? The ho and the ha, right? The ho and the ha. What are those called again? The actual hypotheses, right? You have a null and alternative hypotheses. I'm actually going to say that you're going to not only state your hypotheses, but you're also going to name your test. Okay? Looking back on grading rubrics from AP, that is part of the grading rubric, is being able to list the name of the test. And remember how I said there's like 15 or something that we're going to do? We're going to be doing a lot of them. So it's going to be important to tell the person who is reading your exam question which test you're going to be performing. So we're going to not only name our hypotheses, but we'll name our test as well. What's step 2? Think about confidence intervals. What do we have to be able to do in order to be able to use the formulas? The conditions, right? So we're going to need to check the conditions. And those conditions are going to be based on the test that you're performing, correct? So that's why it's important to name your test to begin with. So we're going to check the conditions. And then if you remember, we skipped 3 and 4 and we jumped right down to option 5 or step 5. And what was the very last thing that you're going to do? We're going to make a conclusion. And we're going to make that conclusion in context. And it is a 2-part conclusion, and when we get to that, you have to decide whether you reject the null or fail to reject the null. We'll talk about what that looks like, and then you're going to actually write it in the context of the problem. Steps 3 and 4 we kind of skimmed over because we really just talked about, based on your hypotheses, what kind of conclusions are we looking at. And we're going to look more at that today. But steps 3 and 4 are important. I'm just going to tell you what they are. So step 3 is going to be to find what's called the test statistic. And the test statistic, the two that we know of right now is a z-score and a t-score, okay? And we'll look, if we get to it today, hopefully time-wise, we'll look at formulas to find those, but we kind of know what they are already. And that's on your pink sheet, actually. I think it's your parameter minus your statistic all over the standard deviation of the statistic, right? So we know what that looks like. And then number 4 is going to be to find something called the p-value. Okay, p-value is not p, it's not p-hat. Don't you love that we have to have the same letter that describes 3 completely, totally different things? So we're going to look at something called the p-value. The p-value is a probability. Do you remember what it is? Let's define it real quick. We have defined it before. Do you remember how we defined it? It's a probability or the likelihood that our result would happen. I'll write it down since we don't seem to remember. So this is going to be the likelihood or the probability that our sample happened by chance or given that the null was true. Okay? So assuming that remember the null hypothesis is going to be your status quo, it's the claim, it's what we think, like it's what's assumed, okay, is your null. And then we're trying the alternative hypothesis is what we're trying to prove wrong. Okay, we're trying to prove this is wrong, we're trying to prove that this is true. So the alternative is what we're testing. The null hypothesis is kind of the claim or the status quo. So we're going to assume that that status quo is true, and then the p-value is the likelihood that our sample would happen given that that's true. What kind of a p-value are we looking for? A high p-value or a low p-value? We want a very small p-value, actually, okay? So we want a very small p-value. And we'll talk about what small means, okay? And we're going to be actually doing a comparison. We're going to compare a p-value to a number to be able to make a decision that will help us with our conclusion, okay? So we're looking for a small p-value. We don't want our, I think we did a free throw shooter, is that right, where we talked about that example in class? And we said that, you know, the likelihood that, I think they had, what, they claimed 80%, and then our sample was 64. I'm trying to remember exactly the numbers, but if you look back at those at that lecture, you'll see that we wanted that the likelihood that our sample happened was really, really small. Remember the little distribution with all the dots, and then our p-value was way at the end. It was very, very small, and that's good. That means we can prove you're a liar, you little bucket kid, you, right? You can just prove them wrong and say, you know, you don't shoot 80%. Okay, don't lie to me, right, Mason? Don't lie to me. I have statistics that prove you wrong. That's the kind of thing we're looking at. Okay, we're looking at trying to see, does our sample happen by chance? That's an overview, very, very, aerial view of what a significance test, at least the steps to it, are. Today we're going to talk about errors that can happen based on our conclusion. Okay? So we'll get to the step, we're going to do hopefully a full test today from beginning to end, and we'll be spending the next month doing full tests from beginning to end for a while. But we're going to spend today looking at what happens if I make the wrong conclusion and what happens if I make the right conclusion. Okay? So we'll get to the details and the nitty-gritty and the math eventually, but let's talk about the errors that could happen. Okay? So there are two errors. There's things called a type 1 and a type 2 error. What I'd like for you guys to do is I'd like for you to look at your assignment sheet on the back, if you don't mind, and look at your table that you see, and so that way you don't have to copy it down. You have it already there, right? So what I'd like us to do is let's see if this kind of makes sense to us. The null hypothesis, which is the status quo, which is the claim, right, can either be true or false. Do you agree? So I claim that this kid claims he's an 80% free throw shooter. It's either true or it's false, right? So the truth about the null hypothesis, the truth about the population, right? And then we make a conclusion. We either say that you're a liar or you're not, right? So we have kind of a two-way table going, so to speak. And these are what can happen. So we can either, by the way, we either reject or fail to reject. Please never say that you accept anything. So be careful with the wording, okay? We can have evidence against something that would support something else, but we never say, yes, it's 100% true based on my statistics. Remember, statistics is vague, right? We never say 100%, yes, this is true. So these are the words, the vocabulary that you're going to be using is reject or fail to reject, okay? So we either reject or fail to reject based on our p-value. Remember, we want a small p-value. So we make a decision based on that p-value, and we can either make an error in either case, okay? And we're going to talk about those in context here in just a couple minutes. We also can make some correct conclusions, okay? I can reject the null because our 80% free throw shooter claim and our statistics prove that we have a very small p-value, the likelihood that our sample happened by chance, that would be a correct conclusion, right? So that's called the power of the test. So you would add that to your little table. It's not listed there. Yes. Is it red? Is it gone? No. Thank you for checking, though. Yeah. Okay. Mike, can you see it? The red light? I'll just keep checking. You have no idea what just happened, but that's okay. All right, so power of the test is when you make this particular correct conclusion. You reject the null hypothesis when it in fact was false. All right, that's a correct conclusion, right? You also have a correct conclusion if you don't reject the null and it was true. Okay? That's just a correct conclusion. Any questions about the chart? We're going to look at how these things kind of relate to one another. There are some letters, some Greek letters that are associated with the types of errors. The type 1 error, is called is alpha. It's also your significance level. So if we're talking about a 99% confidence, that would be a 0.01 significance. That's kind of important. Let me write that down. So if I have like a 99% confidence interval, that correlates, or that's the same thing as looking at a hypothesis test at a 0.01 significance level. Okay? What would happen if I had a 95% confidence interval? What would the significance level be associated with that? 0.05, right? These are, in fact, they add to be 1, right? Okay? They're what? Not inverses. They add to be 1. Okay? So that's important. So you might hear me say alpha. You might hear me say the significance level. Okay? But they are, in fact, related to the confidence level that we have already talked about with confidence intervals. Alpha is also the probability of making a type 1 error. So those are exact numbers. So that's kind of nice. Type 2 errors are noted by what's called the beta. Okay? So you have alpha and you have beta. Just terms of notation, that's really all we care about right now. Okay? And the power of the test and a type 2 error, these two guys also add to be 1. Okay? So in other words, if we wanted to find the probability of making a type 2 error, by the way, that's a really difficult calculation, and you'll never be asked to do that. The only thing you'll be asked to do is if I gave you the power, could you find the type 2? Yes, you just subtract them from 1. So these two things, the probabilities add to be 1. Okay? They are complementary of each other. Okay. A lot of information right there. Okay, let's try to apply it a little bit. So, let's look at an example. Okay? Let me turn the lights out so you guys can read this. I hate that we're turning lights out. It's going to make some people tired, but we'll be okay. All right, so a potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of potatoes from the shipment. Now, that makes sense because they can't inspect every single potato, right? So a random sample makes sense in this context. The producer will then perform a significance test using the hypotheses. Now, let's look at those two hypotheses, the ho and the ha, and let's see if they make sense. Look at the initial, the null hypothesis, okay? P, first of all, why am I using P? That's not the p-value. The p-value is something that you're going to calculate and find with either normal CDF or TCDF. It's a probability. P is the proportion. Isn't that the true proportion? It's the parameter, okay? So in this case, the parameter, the claim, we're talking about 8%. Does that make sense? That's a status quo. Anything greater than 8%, what's going to happen? The potatoes will be sent back. So do we understand the difference in the two hypotheses? Let's write them in context, okay? So let's actually try this. So this is going to be 8% of potatoes have blemishes, right? And you guys can't read that, but you can just pretend that it says blemishes. And then here is going to be more than 8% have blemishes. Are we okay with that? Numbers, words. Important to do both. So P, and remember, all of our hypotheses are always, always, always written in terms of the parameter. So with proportions or percents, like you have 8%, proportions are going to be P. What would we write them in terms of means? What's the parameter of a mean? Y'all are scaring me. Mu, right? Remember we talked about this? So if we go back here just for a second, let's just refresh our memory when we're talking about parameters versus statistics. And we talk about proportions. We have P and P hat. I noticed on your parameter, on your confidence interval for proportions quiz, some people got confused on that. And then we talk about means. We have mu and x bar, right? Just notationally, okay? Your hypotheses are always going to be written, in terms of these two guys, because we're making claims about the population. All right. So let's describe a type 1 and a type 2 error in this setting, and let's talk about the consequences of each. So I'm going to pause the recording for a minute, turn the lights back up, and I want you guys to look at your table that you have on your desk, the one on your assignment sheet, and I want you to think about if I reject the null or don't reject, if I say that this is true or is not true, what's going to happen, okay? So look at what type 1 error is and type 2 errors. Talk amongst yourselves while I put attendance in, and then we'll kind of come back, okay? So let's see if we can't put this in words. So let's talk about what type 1 error would be. Let's label each. I tend, just for my own sake to help me remember, tend to write without context first and then add context. So without context, what is a type 1 error? If you look at your table, it's when you reject the null when you shouldn't have, right? That's what that's saying. So let's write that here. So it's when you reject the null. And remember, why am I rejecting the null? When my p-value, the likelihood that my sample happened by chance, when my p-value is small, I'm going to reject the null, okay? So I reject the null when I shouldn't have. Maybe I had a bad sample. Maybe it wasn't an SRS. Maybe the way that the sample was collected was a problem. There's lots of reasons why the sample we have might produce a small enough p-value that we would tend to reject it. What is this going to be in context? So I'm going to say that 8% of potatoes, so what am I doing? I'm sending the truck back, right? I rejected the null, so I'm sending the truck back when the potatoes were actually, they were fine. Would you agree with that? So that's what's happening here. So in context, I'm going to send the potatoes back when they were totally fine. Okay? What might be a consequence of that decision? Wasted money. Would you agree? Now, the consequence might look different from the supplier of the potatoes versus the manufacturer of the potatoes. Would you agree? From a supplier's standpoint, I'm getting potatoes sent back to me that were fine. You think I'm going to be happy about that? Of course not. So from their perspective, a type 1 error is pretty harmful. Wouldn't you agree? Now, if we look at from the perspective of the supplier, not the supplier, sorry, the potato chip maker, the distributor, whatever, not the potato farmers, but the people making the potatoes, what's the consequence in terms of them? Well, they're getting new potatoes, right? So it's really not that much, not that harmful. Might cost money to get a new truckload of potatoes, depends. But it's going to cost money, more money on the supplier, wouldn't you agree? The potato farmers are going to have to, they're wasted a bunch of potatoes for no reason. All right, let's talk about a type 2 error. And a type 2 error, without context, look at your chart, what's actually happening. It's when you fail to reject the null when I should not have, okay? All right? Because the null was true, but I rejected it, okay? I'm sorry, the null is false. It says HA true. I hate that. Ooh. Can I make a change on this? I don't like it. Do you see how it says HO true, HA true? Yeah. Please write HO false. Okay? You can write that above it if you want to. So Kevlin, right here, write HO false above that. Thank you. Okay, so thinking about a type 2 error, okay, I did not reject the null, but it was false, right? That's really what that's saying here. So what about in context, what's happening? What am I doing with the potatoes? Am I sending them back or am I keeping them? I'm keeping the potatoes, and what's going to happen? They were bad. So I'm going to be producing bad potato chips, right? I made a wrong decision. So I'm going to keep the potatoes and they have blemishes, or they were bad, or they're yucky potatoes. You ever get like a brown speck on your potato chip? Grosses me out, right? So what is going to be the consequence of this from each of the perspectives? How about from the manufacturer's perspective? The people making the potatoes. What's a consequence for them? Well, they've made a bunch of bad potatoes, bad potato chips, right? The manufacturer, if they keep it and they shouldn't have, now they've made bad potato chips. Are their customers going to be happy? No. Might they lose business? Sure. So money is always going to be a consequence, okay? Shouldn't say always, often a consequence. What about from the potatoes farmer's perspective? What might be a consequence for them if a type 2 error was made? Well, the potatoes are getting used, right? But what might get damaged? The reputation, right? So there are consequences for both. It just depends on which perspective you're looking at might be which one is the more traumatic, okay? I will say often type 2 errors have a larger consequence, but not always. Just depends on the perspective that you're looking at, okay? Don't you think that using bad potatoes might be a worse consequence than sending good potatoes back? Because at least you're going to have good potatoes in the end. You just wasted money, right? Okay. I'd like to practice this a couple of times before we move on. So I'm going to give you some problems to do. I want you to try problem number 1. So let me go ahead and hand this out. Okay, let's go ahead and talk. Problem number 1, we're really not doing a whole lot. When we get to problem number 2, we're looking at a little bit more detail, okay? But in number 1, did the Cancer Institute reject or fail to reject the null hypothesis? What did they do? They failed to reject the null, okay? So when we're looking at our chart on the back, when I make an incorrect conclusion and I fail to reject the null, isn't that a possibility of a type 2 error? Okay, so that's why part B says, would they be making a type 1 or a type 2 error? That's type 2. Would you agree? Okay. And then letter C is kind of strange. When they talk about proving the absence of effect, the word prove is a really strong word, okay? In statistics, we like to say we have evidence to suggest that something happens, but we can in no way prove that something exists or doesn't exist. So the word prove is the key, like the strong word here. So really how I would comment on this is that we might have evidence to suggest an error. So we might have evidence to suggest a reason why we should reject or fail to reject the null, but prove is too strong of a word. And that's really all you need to worry about in that one. Okay? I'd like you to go ahead and try number 2. That's really all we're going to do, and I'm going to have you do the 3, 4, and 5, and 6 on your own. But I'd like to look at problem number, I'm sorry, I want you to do problem 3. I apologize. Problem number 3. So skip 2. Please go back and attempt number 2 on your own. Derek, come on, I'm talking. So number 3, I'd like for you to go ahead and look at type 1 versus type 2 errors and talk about the context of them and which one might be more serious, okay? So go ahead and jump to problem number 3 and attempt those for me, please. So let's list each of the type 1 and the type 2 errors, and then we'll talk about which one might be more serious in just a second. So let's start with a type 1 error. Again, I like to write what is happening without context first. So without context, what's happening? Look at your chart if you need to remember. Obviously, you can't use that chart on the test or the quiz. So you want to, at least for the beginning, you can start to rely on it, but don't, try some of the homework problems on your own and then look at it. So in a type 1 error, what's happening? I am rejecting what? Rejecting the null, and should I have? No, when I shouldn't have. All right, what's the context here? If I reject the null, what decision is being made in terms of the context? That what? Okay, so in terms of what's going to happen? What's in terms of the decision that's going to be made? So what I'm done here is I've rejected this when I shouldn't have. So it was okay. The river's ecosystem was fine. Would you agree? There was nothing wrong with it. But I said there was. So what impact is that going to have? People are going to have to change practices. Money's going to have to be spent for no reason. Does that make sense? Like extra work is going to have to be done, and it really wasn't necessary. Is that okay to say it that way? So we can put that in context. So we're going to, policies might have been forced to be changed, or extra, I don't even know what they would do to figure that out. But so we'll just say that, should we say policies? What should we say? How should we write this in context? Huh? So we'll say regulations would have to go into place. So they would be put into place unnecessarily. And I would say it would cost money. Would you agree with that? Money and time, I would agree with that too. Would you agree with that? All right, so money and time are spent unnecessarily. The unnecessarily is the key word there. How about a type 2 error? What's happening here? So not in context, it's going to be when I fail to reject when I should have, right? How about in context? What's happening? I say the ecosystem is fine, right? Nothing's wrong. The mean water temperature is okay. But what is it really? Not okay, right? So what's a consequence? People die, right? And that's often a consequence for a type 2 error. I hate to say that, but like death is usually a consequence. So it's like, that's why I said oftentimes, depending on the perspective, I mean, from a power plant's perspective, a type 2 error is okay. I'm fine. I don't care about the ecosystem, right? Right? I'm good. But from an agricultural standpoint, or from an environmental standpoint, better way to say it, it's horrible. Would you agree? It's detrimental to the ecosystem. So I would just say, so it's detrimental to the ecosystem because nothing would happen to save it, right? Which one do you think is more serious in this case? Type 2, I would say, if you are an environmental, champion, then I would definitely say type 2. If you just care about money and making bucks, then type 1 probably is okay. Would you agree? So, anyway, yes. Uh-huh.
Like in this album, it seems like there's not two things going on, but they talk about the plant being in compliance with the regular. Okay, please.
So you want to look at the null and alternative hypotheses because that's what you're doing is a decision based on that, right? So that we're saying that the mean temperature either is 150 or it's not, right? So we're either rejecting it or we're failing to reject it, right? So, sorry. So you really want to go back to this. So you're talking about mean water temperature. And then you can go back into it and say, well, if the mean water temperature is higher than 150, like our evidence shows that it is, then we can talk about what's happening with the ecosystem. But you want to refer back to the mean temperature. Great question. Anything else? Okay. Let's go ahead. So go ahead and put this away for me, you guys. I would like for you to practice a couple problems. Let me tell you that 4B and 6B, circle those. 4B and 6B, they're the same type of question. I'm going to tell you where in the book you can find the answer. Okay? So on problems 4B and 6B, it's asking you about which significance level would you prefer to have and why. So you want to read on page 544 in your textbook the explanation of step 2. So I'd like for you to do that before Thursday, okay? Is today Tuesday? I don't even know what that day is. Before Friday. I'd like for you to look at that so we can talk about those specifically. Is that okay? So part of your homework is going to be to answer those two questions based on that explanation. Okay, perfect. So I'd like to talk a little bit about the relationship between a type 1 and a type 2 error versus the power of the test and things like that. So we already answered this question, sorry. So this is kind of an interesting look. Let me turn the lights back out here. An interesting look at the relationship between a type 1 and a type 2 error, okay? So here, this tail probability that's being shaded is the probability of a type 1 error. It's your alpha level, okay? Here is your p hat, okay, is that straight line. And based on your sample results, that can kind of slide around. Do you agree? So just based on your sample, you can have that kind of look at it. Sample proportions to the right of whatever our p hat is, which happens to be 0.0999, whatever, will cause us to reject null even though it's true. That's an example of a type 1 error, okay? I've already talked about significance level, sorry. All right, what about type 2 errors, okay? So a type 2 error, we've already talked about what it is, and here's the definition. I've also said that the power of a test is the complement of a type 2 error, right? So we know that the power, and I've said this already, but in case you didn't get it the first time, is just going to be the complement of the probability of making a type 2 error, which is B, beta, right? And a power is what we want. We want a strong power. We made a correct decision when we should have, okay? That's a power of the test. When we actually reject the null, our evidence suggests we should. They're a bunch of liars, and we have evidence to support it. We made a correct decision. That is a power. We want strong power. So we're looking for ways that we can increase that power. And there's a relationship between the power and the probability of a type 2 error. There's also a relationship between the probability of a type 1 and a type 2 error. So here we go. A lot of stuff on this slide. Okay, so Again, probability of a type 1 error is over here, okay? The power of a test, we've already talked about that. We've already talked about all of that. This is not what I'm looking for, sorry. Here we go, this is the one I want. All right, so when I look here, okay, we have a sampling distribution of p hat if the null is false, and we have based on if the null is false, here's a decision that we're going to make based on the type 2 error. So over here, we have that the power of the test is going to be whatever shaded to the right here. It's kind of a strong power. Here's a type 2 error. Remember that these two things add to be what? 1, right? So we want this kind of this line here to kind of slide to the left a little bit so our power is strong. We want a strong power. That's a correct decision. We want a probability of a type 2 error to be small, right? Although 0.2483 is pretty big, so we don't want that. I already told you you're never going to have to find that on its own, right? I hope I told you that. Good. Excuse me. All right. How large of a sample must we take to be able to minimize the errors is basically what this is saying, okay? And this, if you guys are in, I don't know about AP Bio, but I know that in the capstone program, Derek, what class specifically are you in? Research. I know in research for sure you have to carry out a test, collect some data and answer some questions. And that's typically what we do at the end of the year project for statistics as well. But that takes some time, and so we're not sure about what we're going to be able to do. But one of the questions you would ask yourself is, we want to be able to figure out how large of a sample do I need? And that's an important question. So if we want a small significance level, okay, which is what we want 1% rather than 5%. Typically, you want a small significance level. You have to take a larger sample. That's important. I'd write that down, okay? Larger the sample, the smaller the alpha. We can even just write it down as basic as that, okay? So if you want a smaller alpha, you must take a larger sample, right? A smaller significance level requires stronger evidence to reject the null. So the larger sample you have, the more evidence you have, right? You have more data points to be able, the more reliable it is. It just can't be larger than 10% of the population, right? If you insist on a higher power, remember we want power, don't we? We want the power of the test. We want that strength. So if we want a power such as 99%, you will need a larger sample. So again, higher power. I wish there was a symbol for power, but there's not. Higher power, larger sample. So larger samples not only increase the power, they allow you to have a smaller significance level. And that's important because you're actually comparing your alpha to your p-value eventually to make the decision. So you want a smaller significance level. Okay? All right. Any questions about those two things? Those I can almost, I shouldn't say guarantee. Those are likely multiple choice questions, okay, on a test or a quiz. What would increase the power? What would decrease the power? Those kind of things. Those are likely multiple choice questions. Okay. So we already know this is kind of like just a summary of the basics here. We know how to reject a null because we want a small p-value, right? P-value is a probability. We'll go ahead and look at that information eventually here in a couple minutes. Type 1 errors, just kind of a summary of what it is, summary of what a power is, and you guys can print those off. You don't have to write it all down. Okay? Feel good? Any questions so far? I'd like for you guys to, what I say, do 4B and 6B, right, on these. That's what I'll be looking for specifically, but if you have questions on any of them, bring them on class on Friday. Fair enough? Okay. What I'd like to also do now is hand something out real quick. So we're going to go ahead and start the next section since we're behind because of last Friday, so at least we get an idea. And I'd like us to do a hypothesis test from beginning to end, okay, on one of these sheets that I just handed you. So let's go ahead and find one that we can actually do, and let's relate it to what we see here, okay? Remember, we talked about the basketball shooter at the beginning of class. Let's go back to that example, okay? So recall our basketball player. I'm going to cover this up because you don't want to see all of it. There we go. Who claimed to be an 80% free throw shooter. In an SRS of 50 free throws, he made 32. His sample proportion of made shots is 32 out of 50, is much lower than what he claimed. Does it provide convincing evidence against his claim? That question, convincing evidence, says one of two things. One, you're either going to do a confidence interval, or two, you're going to do a significance test, okay? It means you're going to do something with inference. So I'd like us to do both here, if we can, on this one. This is double-sided, so you have 4 total. So pick one side of one sheet, and let's do this problem from beginning to end. Fair enough? So we have a practice of doing a hypothesis test. So what would, if you look at the parameter of interest, parameter, by the way, does mean population, right? So what is the parameter of interest here? The proportion, better say the word proportion, it's the true proportion of what? Free throws, okay? So when you guys, I'm going to give you, I'll let you look at your quizzes during, we'll see how much time we have, either today or next class. But that was something a lot of people missed. Was, can you actually tell me what a P is? What the parameter of interest is? In this case, it's P, right? Not P hat. P hat is not a parameter. So you better not say that the parameter of interest is 32 over 50, because that's wrong. Okay? The parameter of interest is the true proportion of free throws made. Does that make sense? Yes? No? Okay. Step 2, it says to create your null and alternative hypotheses. So I've covered them up because I want you to come up with what they should be. The null hypothesis should be what? P equals or mu equals? Hey, Derek, come on, dude. P equals or mu equals? P, thank you. It's a proportion, right? So P equals what? Remember, it's always equals. What's the claim? 0.8, okay? So P equals 0.8 is going to be the null hypothesis. What's the alternative? Because it says against his claim. Do we have evidence? P is less than 0.8, okay? You probably need to write those in words as well. So in other words, we should say the true proportion. I need to be skinnier. Let's see if I can make it thinner. How would I do that? All right, so this is going to be the true proportion of free throws is 0.8. That's your null. And your alternative would be the true proportion of free throws is what? Less than 3.8. Okay, so in context and in letters. Okay? All right, the next step says choice of test. So what test is this going to be? Well, we know it has something to do with proportions, right? This is a one sample proportion because we have one sample. We have the 32 over 50 is our one sample that we collected. We will eventually be doing more than one sample. This is a one sample proportion. Okay, so one proportion. And when we deal with proportions, am I dealing with normal distributions or am I dealing with t distributions? You guys are tired. Do normal, okay? So this is called a one proportion z test. Okay, let's write that down. So this is a one proportion z-test. That's what it's called, z, because the z-score is associated with normal distributions, and it is one proportion. That's the name of the test we're going to perform. Okay? All right, as we keep going, number 5, check the assumptions. Okay, so what are the assumptions for a one proportion z-test, or conditions? Think about what we did with confidence intervals. We have 3. What are they? Random sample, so we're looking for an SRS or a random sample. If it doesn't say it, we have to assume it. Okay, you still need to say that. What's the second one? N times P is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. So on the left-hand side where it says statement, that's what you should be writing, and on the right-hand side you'll put the numbers in. Okay? What's the third condition? The 10% condition, correct? The independence condition. So here we have, sometimes this is called the normal condition, sometimes this is called the independence condition. So let's put the numbers in. Does it state in the problem that it's an SRS? I don't think it does. Oh, I lied. Look at that. SRS. So is it an SRS? Yes. How about number 2? What's P? 0.8, not the p hat, but the p, right? So in this case, we have that our sample of 50 times 0.8, is that greater than or equal to 10? What's 80% of 50? I didn't hear you. I have a hearing problem. Yeah. So 40 is greater than or equal to 10. And then n times 1 minus p, what's 20% of 50? 10, right? So we are just large enough sample. Would you agree? Just big enough. So we're okay. 10% condition, what do I say to that? 50 is our sample size, right? So what do we say about 50?